So I hope that we'll not die without internet, but you can trust me that doing live coding without internet now will be pretty hard. So let's go. So we don't have a lot of time, and I think it will be the fastest live coding in my life. So let's don't lose the time. But let's start with some history at the beginning. So when I was starting to learn code, most of the tutorials was focused on some building some websites, sometimes with some API, some maybe RESTful APIs. It was 13 years ago, so you know it. A lot of change from this time, but I think this particular thing, it's pretty the same. I mean, when you're learning how to code, you're not starting probably with creating some event-driven application based on Kafka, because it will be just too complicated for you. But unfortunately, building only applications only in synchronous way, it's not the always best case. So you can have some issues like cascading failures, slow request, or coupling between services. And yeah, it's not probably the best in our microservices world. And I was working in some projects some longer time ago, and we had two pretty important requirements. So the first one was some complex search functionality. So it was complex enough that it was basically just pointless to use some MySQL, for example, for searching here. So it was much better idea to use Elasticsearch in this case. And the second also really important requirement was some kind of personalized feed. So I will compare to how it's working in Facebook or Twitter. So in case when you are liking some kind of content or following some kind of people, you automatically see much more content of this type on the wall. And this was basically the idea. But it was one problem with architecture like this. So let's imagine that this part, what I shown here, is synchronous. So, and let's imagine that, for example, we are so followed by, I don't know, 10,000 users. And in this case, you know, adding one tweet can take even, I don't know, 1 minute, because you need to personalize every wall, you need to create some search models, etc., etc. So I think it doesn't sound like a really good user experience to adding a tweet for 1 minute. And you can also imagine what if something went wrong. So for example, something went wrong in the middle of personalizing the content. So it doesn't sound like a good idea in general. So it was pretty obvious for decision for us to use some event-driven architecture. And already a couple of us in team have some experience with Kafka. And you know, Kafka is scalable, it's nice, etc., etc. So we decided to go with Kafka. What can go wrong? Well, you know how it's with problems. Yeah. So in most cases, these problems are not magically disappearing. In most cases, their problems are moved somewhere, or just you have another type of problem instead. And in this case, it wasn't differently. So in this case, the first problem was that, yeah, actually Kafka is really nice, but it's not really simple to understand how everything is working. So you need to know some stuff about consumer groups, partitioning, of course, message acknowledge, negative acknowledge. So you need to, for example, say Kafka, okay, I processed this message, it's fine. But it's may sound pretty simple, but in practice, it's a bit more complex if something went wrong, of course. So it's pretty simple to lose some messages. And okay, it depends on domain, because in some domains, okay, it's just we lose one message, but in some domains, so for example, now I'm working with a financial domain. So this one message, let's imagine that this one message was initializing money transfer for a big amount of money, and you would just lose this message. So it can have pretty big implications. But it was not the last problem, and I think it was not even, we had even one bigger problem. And as I mentioned at the beginning, so when people are learning programming, they are not starting with Kafka event-driven architectures. They are starting with some HTTP applications, and sometimes they're unfortunately stopping on this level. And yeah, we was in kind of pretty similar situation that, okay, some part of team have already some experience with Kafka and event-driven, but some part, unfortunately not. And basically during this time, I asked me one pretty important question. And the question was basically, how I can make building event-driven applications easy in Go. And by easy, I mean, as Natalie mentioned, as easy as building, for example, some HTTP endpoints. And this is basically how Watermill was born. And currently, we can say that we have almost 2,000 stars in GitHub. So probably it means that somebody is even using this library. Already 20 people helped, probably more than 20 people now, helped us with building this project. So thank you very much if you are in this stream for helping us. And we are supporting 8 different PubSub implementations. And what is the most important? We have logo. We have logo with Gopher vomiting to Kubernetes logo. Don't ask me why, but yeah, it's true. And yes, as I mentioned, we are now supporting 8 different PubSub implementations. And what is pretty nice, you are able to pretty easily change an implementation to another implementation. So if you was using some ORMs before, so I think it's pretty similar. So when you are going from MySQL to Postgres, it's pretty similar. It's pretty simple operation, and it's in most cases just changing some configuration. Of course, if you are using something more advanced, characteristics of them are a bit different. But if you would like, for example, to go from Kafka to RabbitMQ, from unknown for me reason, but you can, it should be really, really simple operation. And all right, you may say that everything sounds pretty good, but how is everything done? So at the very beginning, when I started to think how it can work, I would say that it taken into my heart the Unix philosophy. So it's some pretty old already philosophy, but I think it's really, really valid still. So, but the only update will be that we're not writing programs to handle text streams, but yeah, messages in this case. But how it's implemented in practice. So in practice, in really, really, really simple words, I would say that Watermill is composed from 3 different interfaces. So two first of them are publisher and subscriber. And publisher is used for publishing messages. Yeah, pretty obvious. And subscriber, you're right, it's for getting these messages from message broker in this case. So you may see that we are just receiving these messages with normal Golang channel. I think nothing fancy. And what is also important, when you would like to implement any new PubSub implementation, the only thing which you need to do is just to implement this interface, nothing more. And the third, probably even more important type, it's a handler function. So if you think about any event-driven application, in practice, you can build it from some limited amount of functions like this. I mean, every application is consuming some message, and in some cases, it's emitting some message. Nothing fancy, basically. And of course, you can emit, you can have some side effects here, but it's up to you to put to this function, basically. And also, so when you are creating a library like Watermill, you need to be really, really sure that this library is stable and you can basically trust this library. Because, as I said, some domains require really extreme consistency. And in this case, well, we cannot just lose one message. So to achieve this, we created some kind of universal publish subscribe test. So the idea is that basically every PubSub is working in the same way. You have some message, you are emitting this message, and you are expecting to have this message from PubSub. You know, RabbitMQ is working like this, Kafka is working like this, everything. But of course, we have some details under the hood. So for example, not every PubSub have some functionality similar to consumer groups. Not every PubSub have exactly once delivery. Almost no PubSub have basically exactly once delivery. Not every PubSub have, for example, guaranteed order. But if you, so you are able to pass this test configuration to your tests, and you are, but everything under the hood is working the same. And what is also pretty important, when you are implementing a new PubSub, you don't need to really think about adding a new test. So you should be able to just use the tests that are already created, provide some characteristics that you can see here, and it should work. And we already do it like that, for example, for Google Cloud PubSub. So we just used the test that we created earlier, and we didn't have any production system to test it earlier, but we implemented everything with tests. And after, when we have opportunity to use it in production, it was working without any problem. So I think it's showing how powerful all these tests. But it's not all about tests, because we need to be also sure that Watermill can work under a really heavy load. So what is the idea to check this? So let's just get all the tests, what I mentioned earlier, and run it 10 times in parallel. So you can imagine that it's creating a lot of load, but still every message that was sent should be delivered in some good time. And one important thing is also how fast you use Watermill. So of course, some of you probably have pretty high requirements of how fast the libraries are that you are using. And so for that, Miłosz from our team created a benchmark. And what is also pretty important, this benchmark was done from one process, from one virtual machine, from one Docker compose. Because in theory, we can add million of Kafka clusters, etc., and to try to measure this, but I think it's pretty pointless. So we decided just to create it from one process. So you can see that these numbers are pretty nice. And what is also pretty interesting, we have MySQL pops up, for example, and it's able to subscribe to only 143 messages per second, but it's 20 million per day. So it's still maybe pretty interesting for some smaller applications, and it's pretty interesting also because it's have exactly once delivery ability. So for some use cases, it may be also pretty useful. All right, so this is about the history, I would say. But do you know the first rule of live coding? Of course, you cannot answer me, so I will answer instead of you. So the first rule of live coding is don't do live coding. So let's do live coding because I think it's a great idea. Okay. So I prepared some simple application, and this is application for booking hotel rooms. And what we have inside? So I prepared some Docker compose. So we have Kafka, we have Zookeeper, and we have some application container. And what is interesting with this application container, we have also reflex here, reflex, yeah, if I remember here, and it give us ability to reload this container after any change. So it's pretty nice. So let's change something, and you can see that it's recompiling. Yeah, so it will live. Will save a lot of time thanks to this. But later I will post a link to our blog. So in this blog we describe basically how to do it in a really simple way. And it's also really lightweight, so I think it's nice because of that. So what we have in our application? So we have some simple tree router, we have some boring signals handling. Let's skip that one. Let's check our what is here. Or maybe earlier, let's try to use our application. So it have a REST API to give us ability to book a hotel room. And let's see. Okay, it's not working. Oh, it worked. Great. It's not working. Worked. Now it's working really, really slow. So as you can see, probably it's not providing the best user experience if it's mostly not working or not working and slowly not working. I think it's the worst scenario. So let's check what we have inside. So yeah, you can see that it's very simple tree router. So let's check what we have inside of our handler. So we have we have our request, so we can provide room ID, we can provide guest count, and nothing fancy. Yeah? So we have our request, we are unmarshalling it with JSON, we have some really complex algorithm of calculating a room price, and we are taking payment. What can go wrong here? Oh, and as you can see, our payment provider is not the best one, unfortunately. But let's imagine that we cannot change this payment provider because some political reason, whatever. It just cannot. So what we can do in this scenario? So my proposition will be, let's use Watermill and let's try to do it asynchronously. I think in a way it's a pretty good idea to do such kind of operations asynchronously when we are calling some external service and we know that it's not really stable. So what we need to do? So we need to, so my idea for this, so let's emit some event from this place that, okay, room was booked, and let's listen for this event, and let's try to trigger this handler by this event. So let's go. So the first thing that we need to do, so let's change this payment provider here with publisher. We have, so you may remember this interface. So this is this Watermill publisher interface, and we don't need this guy now. So H publisher publish. So let's publish it to topic bookings. And we need to have message. Okay, and so this is a Watermill message. So what we need to have in minimal Watermill message? So we need to have UID of this, and we need to have payload. So UID, it can be any string, basically. It can be even empty string, but I can imagine that probably it will be not the easiest one for debug. And we do also provide payload. And payload is just slice of bytes. So we can put anything here. So let's create our payload. Let's start maybe with event. So let's name our event room booked. I have some code snippets to not lose a lot of time for writing this. So you can see room ID, that in this event will emit room ID, guest count, and price that we just calculate. So And of course, I'm not recommending to panic in HTTP handlers, but it's just faster for live coding. So don't tell anyone that Robert said, yeah, let's panic in HTTP handlers. All right, so I think it should be enough. So we are marshalling our event with JSON, and we are publishing our event. So we have the first part, and the second part will be event handler. So this is the place when we are handling our event. Like this. So in theory, we can just provide a function, but I will recommend to use struct because we can easier inject some dependencies here. So we have room booked event. And so we are marshalling room booked from the message that we just published, and the payload that we published earlier is available here. So let's now rename it maybe to room booked. And now we need to take payment. Provider price. Yeah, unfortunately, in a Watermill handlers, we are able to return error, so we don't need to panic in every place. And I think it will be also a pretty great idea to emit some event after we succeed. Payment take. Yeah, so we have our payment taken event. And that, what is going on? Oh. Okay, room booked. Room ID. Room booked price. And let's marshal it with JSON also. And let's create message. All right. So it should probably work. Almost work. Okay, we need to do one more thing. So we already changed some part of code, but we need to have also some glue. I mean, this payments handler is not used anywhere, and we need to connect this. So let's use Kafka, because I heard that Kafka is nice. So I also have some snippet for that. So it's everything in the documentation, so I will not go into the details of that. And it's nothing more complex here. So it's just some default configurations. So we have our subscriber, we have our publisher. So we need to inject our publisher to room booking handler. And in theory, we could use subscribe method from subscriber, but it's really low level. And in Watermill, we have some high level interface for that. And it's named event router. So basically, it's working more or less like HTTP router. The only difference is, that instead of handling HTTP requests, we are routing messages. So let's create our router. And it's also just before the configuration from the documentation. Let's add a handler. So handler will be named payments. Subscribe topic, so bookings. So this is the topic that I used before to emit the event. So basically, from this events from this topic will trigger this handler. Subscriber, we have our subscriber. Publish topic, let's name payments, and publisher. Great. And what we are missing, and handler function. Yeah. So payments handler and handler. All right, and now let's run our router. Like that. All right, and I think it should work. So let's check. Okay, I see that it's compiling. We have some garbage logs here. Great. So let's use mill. So mill is part of Watermill, but it's used for consuming some messages from topics. So if you know Kafka, it's something really similar to Kafka console consumer. The only difference is basically that instead of consuming, you're able to use it for multiple paths. So it's pretty nice. And okay, so we are just consuming bookings and payments topic from Kafka. And let's call our API now. As Canute can see, it's working pretty fast. And it's working, yeah. So I think it's great. And as you can see, we're also receiving some events here. So you can see that we are taking payments and everyone is happy. But it's not perfect still, because I heard from colleagues that it's nice to be cloud native in these times, because you can put it to your CV. So let's try to become cloud native in 1 minute. Do you think that I can do this? I think I can. So let's try. So the first thing that we need to do is let's change Kafka with Google Cloud PubSub. So new subscriber, Google Cloud subscriber config, Watermill logger, and let's change publisher. And let's check if it's compiling. Okay, it's compiling. So let's use also, oh no. Okay. Okay, so let's use now mill for consuming it from Google Cloud PubSub, as you can see. So, okay, we're consuming also bookings and payments, and let's call our HTTP requests. Okay, it's going out here. Oh, great, and it's working. So I think I even did in half minute. So I think it's world record of becoming cloud native. So I think it's all from live coding. So it's only one thing that I would like to show you, because you may notice that, okay, it's a lot of some boring stuff like JSON Marshall, some UIDs, messages. I think we all don't want to do it for entire of our life to Marshall JSONs. So we prepared also something which is named the CQRS component. So CQRS component is some kind of higher level API of Watermill. And instead of doing all this low level stuff, the only thing when we would like to handle some event is to implement just one interface. So this interface requires from your handler name, new event, and handle. So you may see that we have this room booked event here, and there's no any JSON. So we are just receiving this event in this handle function. Of course, it's empty interface because generics. Well, but I haven't no better idea for that. And we are taking our payment here. And when we are also publishing the event, we are not doing any Marshall JSON, any Watermill messages. It's everything done under the hood. So I think it's also really nice when you have some really event-driven application. And I think it's all from the live coding. So, okay, we didn't lose internet, so it's great. So, of course, it's hard in 13 minutes to show you all Kafka and Google Cloud PubSub internals. I think it's even impossible. So, if you would like to check this topic deeper, probably you need to at least know some basics of how it's working. It's also really important to know how at least once delivery is working, because it's important for every basically system that we are creating with events, messages, etc., etc., etc. And what is also nice, it's middleware system. So it's working also really similar for HTTP1. The only difference is, yeah, again, we are not working with messages. Sorry, we're working with messages, not with HTTP requests, but it's working pretty the same. And we have also some nice middleware. So for example, we have the application middleware, which can be used to ensuring that we are handling at least once delivery in a proper way. So it's kind of chaos engineering, I would say. So this is screen from our documentation. I heard that it's pretty nice, so you should also check this one. We have also a lot of examples. So this is not the list of all examples. So this is the list of just basic examples. So you should check also our GitHub for that. And yeah, and if you like my presentation, also in more or less 2 weeks, we'll release some nice series of articles. So, but it will be not only about event-driven applications, but would like to touch much wider area. So in general, building, I would name it business applications. And I think it will be something totally unique in Go community. So you may ask why. So the main idea is to focus on some typical issues that I've seen in multiple Go projects in multiple places. And in both cases, these problems are stopping us from building applications efficiently. And I think what is more important is also taking some kind of joy of programming away. So nobody likes to probably work a lot with some not nice legacy code. So the idea is to try to avoid this. And it will be also done by refactoring some example open source projects. So I think it will be also pretty unique, because it will be much more visible for you what issues we are solving and how to do this. So I think if you are interested with this, and probably you will be, so you should just check this. So at the slide, there's a link for our blog, basically. This is the link for Watermill.io. So this is a link to our documentation, and this is my Twitter handle. So if you would like to follow what I'm currently doing, so this is probably the best place. And I think that's all. So thank you. Just in time.
Thank you very much, Robert. That was a Really impressive. You know, live demo is never obvious, so kudos to you for that.
Yep.
We don't seem to have questions just yet, but as they start flowing in, will you maybe tell us a little bit about Lara and why did you choose this background for as a fun fact about you?
I have a better one. Yeah, but she's pretty fun. And to be honest, I was a bit skeptical about Doc earlier, but it's pretty nice because you are forced in some way to go outside. So, you know, if you're coding entire day, it's pretty nice because you are forced to go outside to park, etc. If you can. Unfortunately, now it's harder, but yeah. Yeah.
Right, so we have questions coming in, and the first one, if Watermill is event-driven, then why the message handler has to return anything like an array of new messages and error?
Sorry, can you repeat?
If Watermill is event-driven, why the message handler has to return anything, for example, the array of new messages and errors?
All right. So, okay, I didn't also said why I'm sometimes using event, sometimes message. So I would say that message is probably something much low level, I would say. And event is maybe in message, I would say. So if you seen my example, so I was using, so for example, so this is probably the event. So payment taken, this is the event. But if you go here, so we are putting some payload and some low-level stuff inside of this. So, but I think when you are creating some event-driven system, you basically need to, as in this example, you need to say the word that you did something. So as in this example, we need to say that, okay, this payment was taken. But in this case, we are not telling about messages, basically. Yeah? So we have really event bus, etc. So under the hood, it's working more or less like demo that I shown you earlier. So this is the idea, basically. So in simple words, message is something really low level, and event it's some kind of high level stuff.
Okay, next question. Did you check how removing this empty interface affects the overall speed?
Yeah. So I checked this one, and it's not really a big deal. So probably it's affecting it, but so differently. I'm working mostly in some business domain. So, you know, if I will take payment half of millisecond later, it will not be a problem. But if performance is critical for you, probably it's better to use this low-level router. So yeah, so this is the idea for that. So for me, most important here is to use something which is easy to use, so it's simpler to develop. But if you would like to have better performance, it's better to probably go with low-level router.
Okay, cool, thank you. Last question. Any reasoning of not including NSQ as well?
Yes, yes, we can, but probably I will not have enough time now. But if you have some time, it's really welcome. So we have also some information about how to implement PubSubs. So we have a special part of documentation with implementing PubSub tips. So, and we'll be also really happy to help you with implementing this.
Okay. Is there any feature from Go 1.15 that questions suddenly flowing in, flooding the screen? Is there a feature from Go 1.15 that would make Watermill better?
I don't know, to be honest. I didn't check it really accurately, maybe. So probably it may be a good idea to run benchmark. But I think the biggest change will be probably generics, but I'm not really expecting this. I'm thinking also about some interesting stuff about code generation. But still, code generation is a bit tricky. And I think it's really, for example, important when we are using event sourcing, because in event sourcing, it's, for example, in .NET, it's very nice. I've seen some examples from .NET. So I remember that previously it was some examples mentioned of .NET, and it's really nice and clean in how it's done in .NET. In Go, well, we have some internal implementation of event sourcing in Carhu, for example, but there's one function there that even I don't understand, but it's doing some magic in order to cast some types on marshalling. So it's really tricky topic. But for Watermill, I don't know. Probably, I can imagine that it can improve performance a bit. So probably we'll rerun our benchmarks.
Okay. How do you handle Kafka retries with separate topics?
With separate topics. I'm not sure how to understand with separate topics, but how it's working with Kafka. So basically it's pretty universal for every PubSub. So if we are sending negative acknowledge, it maps to Kafka. So how we are doing it in Kafka? So we need to be always sure that, let's imagine that in the middle of processing the message, our service died because, I don't know, it was some kind of meteor hitting the server or whatever. Yeah. So we need to be sure that we didn't commit to Kafka information that we already processed offset. So this is this tricky part that I mentioned during the presentation, that if we'll do it in the wrong way, we can say to Kafka, okay, we're processing this message, but if we will die, please don't resend this message. So this is tricky. Probably it's the best idea. So I'm not sure what is totally what is the for what are you for what are you looking for with this question? But probably you can check the source code or call me on Twitter, so I can probably try to find better answer for you.
Right. There's still some more questions, but we're really out of time. So I will send you the messages. And if you want to answer them on Twitter, you can. And if anybody wants to read the answers, your Twitter handle is on the screen.
Yeah.
And thank you very much again.